All right, we're just going to work on some application problems that relate to addition and subtraction of integers, guys. I'm also going to throw in fractions and then some decimals. But it would just be with addition and subtraction, no multiplication or division. So let's take a look at number 1. And I'm not going to do all these today. It's 24 of them. So I'll probably do 12 today and 12 tomorrow for you. All right, number 1 says, during the football game, Justin caught 3 passes. One was for a touchdown and he went 28 yards. So that's a good thing. The other was for a first down and was for 2 yards. And the other was on a screen pass that did not work out well, and he ended up with a loss of 12 yards. So I need you to write a numerical expression that's going to represent the total yards gained by Justin during the game. Now, with total, you can go ahead and just put plus signs in the middle. But if you do that, then what you'll need to do is make sure you label a loss of 12 as a negative. So if he scored a touchdown and he went 28 yards to score the touchdown, that's positive. That's good. Plus, he scored a first down, and to get the first down, he only had to go 2 yards. That's good. He gained yards. So both of those represent a gain. A gain. Plus, because I'm using plus signs because it says total, there was a loss of 12 yards. Well, I cannot put plus 12 because if I put plus 12, it's going to represent a gain of 12. So I'm going to have to put plus negative 12. So this part represents a loss of 12. Okay. There is also another way you could have written this. You could have went with 28 plus 2, and plus negative is the same as just subtracting 12. This is still a gain, and if you subtract 12, it's still a loss. But if you're ever confused, just use plus signs, and then in the middle if it says total, and just make sure you label it, the numbers, as whether they're positive or negative. All right, so I have a gain of 28 and a gain of 2. So my solution would be 30 plus the loss of negative 12. This goes to the right. This goes to the left. Not loss. So we're going to end up with 30 minus 12. So his total yards gain is 18 yards. That's the total. And even if you work the other expression, suppose you wrote this one, you would still get 18 yards gain. Let's take a look at 2. It says on Monday, the low tide at Cook Inlet, Alaska is negative 1 1/2 feet. On Tuesday, the low tide is negative 1 1/3 feet. So the question asks, how does the low tide on Tuesday compare to the low tide on Monday? Okay. So I want to know what's the comparison from Tuesday to Monday. How does the low tide from Tuesday compare to the low tide on Monday? So this involves order because I got a Monday and a Tuesday. Okay. So I'm going to start off with the final day, which would be Tuesdays minus the start Monday. Monday comes before Tuesday. So on Tuesday, what was the low tide? Let's see. The low tide was negative 1 1/3 minus negative 1 1/2 on Monday. So I don't want you to get confused because of fractions. So if I said on Tuesday, the low tide, on Monday, this was negative 1, we'll take the half off. Sometimes it's easier if we understand just whole numbers or integers. And if I said this was 2 feet, and I asked, how does the low tide on Tuesday compare to the low tide on Monday? Well, I can see that easily it's a a drop of 1 feet if I use just regular numbers like that. So all you have to do is basically subtract -2 minus -1. You're actually finding the difference, guys. So you can see that it is a drop of -1 feet. But these are not integers, they're actual rational numbers, but we call fractions or mixed numbers, guys. So you can't use -2 and 1. I just made those up to get you to see that if you want to figure out how one compares to the other, you basically just subtract, okay? But let's use the real numbers now. Let's go back to the real problem. All right, so I know in order to add and subtract, I'm going to need a common denominator. The common denominator is 6. I'm going to multiply both of those by 2. And both the numerator and denominator here by 3. Now, this would give us, and this is the expression, we will end up with -1 and 2/6 minus -1 and 3/6. So this goes left. This goes right. I'm going to subtract. When you subtract, please put your larger group on top. It's more to the right. So I see that I can subtract. I don't have to regroup. And it's more to the right. So I see that it's equal to 1/6 of a foot more. So in other words, the tide decreased. It went up. So here it was -1 1/2 foot. On Tuesday it was -1 1/3 foot. So it increased 1/6 of a foot. Okay. So from Monday to Tuesday, the tide increased 1/6 of a foot. Hold on. So if that makes sense, it's easy to see. From Monday, from this number to that number, from Monday to Tuesday, it increased 1/6 of a foot. All right, 3, it says in one city it is 62 degrees Fahrenheit. In another city it is -8 degrees Fahrenheit. Let me erase this so you can see. What is the temperature difference between the two cities? Okay, so basically this is regular difference. So before I taught you difference that involved order, if you don't know where you start from and where you go to, then it's just regular difference. For regular difference, it's to always, you put the highest number on top. So you all were taught that from elementary school. If you're finding the difference between two numbers, you put the highest number on top. But when you got to 7th grade, you learned that difference can be positive or it could be negative. It can go in the positive direction or it can go in the negative direction. But in elementary, since you didn't deal with any negatives, again, you were always taught to put the highest number on top. It never involved order. So this says we need to write a numerical expression to represent the difference first. Then we're going to solve it. But be careful because no order is involved. I don't know what city we started in and what city we went to. So if there is no order involved, if you don't know where you started or where you ended, then you just subtract with the highest number first. So we're going to find the difference by subtracting like we normally would. The highest number is 62, so I'm going to have 62 minus the lowest number, which is -8. So highest number minus lowest number. That's the way we normally find difference, guys. Now, if I ask you if I tell you where you started and where you ended, and it has order like that, then you please put the final number first or the end number first. All right, here, let's go ahead and look at 62 minus -8. This is the same. This goes to the right. And minus a negative is a plus. It also goes to the right. So I can say that the difference is a 70-degree difference. Just highest number on top when no order is involved. And what I mean by no order is you don't know where you started. You don't know where you started. You don't know where you ended because it doesn't specify. All right, let's take a look at 4. It says it was a very freaky weather day. The temperature started out at -3 degrees Celsius. That was the start. And then it rose 12 degrees degrees Celsius by noon. It stayed at that temperature for 6 hours. Now, don't put this in there. 6 is in terms of hours. We're looking at temperature. And then it dropped 7 degrees. So it started out at -3. It rose 12. It dropped 7. It says write a numerical expression that can represent the temperature at 6 p.m. Then solve it. So where did I start? Well, I started at -3. Okay, this doesn't involve difference or anything like that. So I don't have to worry about whether it has order in it or doesn't. I just write it from left to right. I don't have to worry about, like I said, what number needs to go first and what number doesn't. It's not difference. Okay, difference is the only one you really need to be concerned about as far as what number should go first. Unless the difference has no order involved in it either. All right, so -3, and then it rose 12. So I'm going to put plus 12. And then it dropped -7. So I'm going to put plus -7. Now this one could have also been written -3 plus 12 and a drop of 7 just could have been -7. Please do not put minus -7. Minus -7 is the same as plus. It didn't rise 7 degrees. So this indicates where it started. This indicates a rise, and this indicates a drop. All right, so I'm going to go ahead and say that this goes to the left. That goes to the right. That goes to the left. So I'm going to group my 2 to the left. That's -10 plus 12, left and right. So I know the ending temperature at 6 p.m. was 2 degrees Celsius. So at 6 p.m. was 2 degrees Celsius. All right, let's take a look at 5. Matter of fact, you can pause the video and you try 5 on your own before I take a look at it. All right, it says a monkey sits on a limb that's 55 feet above the ground. He swings down 10 feet, climbs up 12 more feet, and then jumps down 27 feet. Now, how far off the ground is the monkey? Okay, so I'm just going to go with where he started. This doesn't involve difference, so I start with the first number. I see 55 plus he went down 10 feet, so that'd be plus -10. He went up 12, so plus 12. Plus he went down 27, so that would be plus -27. You could have also written this as 55. And so the plus -10 minus 10 plus 12 minus 27. But this represents where he started. This represents that he went down. This represents that he went up. And this represents that he went down. Be careful that you don't do this, because remember, this is the same as a plus, and it will represent that he went up. You have to make sure that the expression you write matches your scenario, okay? Okay, so what I'm going to do is take all those that go to the right. This goes to the right. This goes to the right. So I know 55 plus 12, so all to the right, is 67 to the right. And then I have -10 and -27 going to the left. So add those up. Remember, same direction, add. Or you can say they both went down the same direction. You still add. So I end up with 67 to the right plus negative 37 to the left. I'm going to subtract. 67 minus 37 is 30. So he ended up 30 feet above the ground. I think I need to spell that correctly. Okay. And that's all you do. But you got to make sure you write the expressions for me, okay? Okay, let's take a look at 6. It says a submarine was situated 238 feet below sea level. Already right there, I know that number is negative 200. I can represent that with a negative 238 feet because it says, uses the word below. It then ascends. Ascends mean it went up 104 feet. So I want you to write an expression to represent its new position. So it started here. So I'm going to put negative 238. If it ascended, it went up. So plus 104. And let's see, that's to the left and that's to the right. Let's subtract. Okay, so it's more left, or we could say it's still below water, so it's going to be negative 134 feet relative to the position it started out with. It started out at. So now it's at 134 feet. 134 feet below sea level instead of 238 feet below sea level. Let's take a look at 7. So we got a path from a dry lake bed, okay? It's starting at an elevation of negative 12.5 feet relative to sea level. The path ends, I got start and ends on this, okay? I'm pretty sure this is going to involve order. Ends at an elevation of 60 and 1/3 feet above sea level. So what number represents the change in elevation from the start to the end? Yeah, that's order. And it's asking about change, which is just difference, guys. So I have to figure out, well, where did I start? Well, I started at negative 12.5. If I want to find a change from one position to another, I just subtract. And it ended right here. So since it's order, I'm going to start off with the final number minus the start number. And I know I don't have a spot on your paper that says expression, but I want you to write it. So I want you to write the expression. Well, what did it stop at? Well, it ended at 60 and 1/3 feet minus, where did it begin? So I'm subtracting a negative. I'm going to put that inside of parentheses. All right, subtract those two numbers, and it's going to give me the change in elevation from one position to another. All right, so the common denominator I can tell is 6. I'm going to multiply both by 2. And both of these, numerator and denominator, by 3. All right, so I'm going to work on my solution. It's going to give me 60 and 2/6 minus negative 12 and 3/6. And this is a plus. So basically, guys, this is regular addition. This is 60 and 2/6 plus 12 and 3/6. So I can just add those up. That's going to be 72 and 5/6 feet. That's 72 and 5/6 feet difference. And you can tell if you started out at negative 12.5 feet and you went up to 60 and 1/3 feet, then you got to go here and here to get that entire difference, which is going to be 72 and 5/6 once you find a common denominator. All right. That was 0. That's the sea level, okay? All right. 8 hummingbirds sip 2.5 fluid ounces of liquid food in a feeder. Okay, so they start off sipping that. Then 1.5 fluid ounces of food is added to the feeder. Okay, so they sip 2.5 fluid ounces, okay, which means it's going away. And then someone adds 1.5 fluid ounces. Later, hummingbirds sip another 3.25 fluid ounces of food, or taken away again. Says, what is the overall change in the amount of food in the feeder? So I'm going to go with where it started. Well, they sipped that, or they took it away. And then they added 1.5 fluid ounces. And then they sipped another 3.25 fluid ounces. What's the overall change? Okay, let's see. The common denominator would be 4. Multiply that by 2, that by 2, that by 2, and that by 2. So I'm going to end up with -2 and 2 fourths plus 1 and 2 fourths minus 3 and 1/4. Now you could have also written it this way. You could have said plus -3 and 1/4. That represents the food is leaving. This represents the food is being added. And this represents the food is leaving again, okay? All right, so what I'm going to do is just go ahead and look at the 2 that goes left. You know what? I'm going to do these 2 right now. Because if I take -2 and they go left and right, if I take -2 and 2 fourths, what ain't no other sign, 2 and 2 fourths, and I subtract 1 and 2 fourths, these cancel. I basically end up with 1. And it's more to the left. So this equals -1 and no fourths minus 3 and 1/4. Well, they both go to the left. So I just add. And I get -4 and 1/4 fluid ounces. In other words, 4 1/4 fluid ounces was taken out overall. Or I can say was sipped overall. But to represent that it was sipped out overall, that's why we need to make sure that our sign is negative, okay? Now, some of you may have chosen to do this. Some of you may have chosen to put the 2 lefts together. And that would have been, let's see, -5 and 3/4. And then you would have had that +1 and 2 fourths. So you still would have got -4 and 1/4, okay? It's just up to you the way you work it. All right, I want you to take a look at number 9. You can pause the video and try it on your own. All right, this is what you should have. Christy is horrible with money. Poor Christy. She opened a bank account and deposited $225. If someone deposits money, that is a very good thing. That's a plus. 2 days later, she made a withdrawal of $90. That's a negative thing. Nobody likes to have money taken out. A day after that, she wrote a check for $115 to cover a purchase. That's also money taken out. Okay, later that same day, she wrote another check for gas, $70. She must own a big truck. She was paid and made a deposit of $75. Well, a deposit is positive. So we're going to write an expression could represent her balance in her account after her last deposit of $75. Then I'm going to solve it. So where did she start? Where she started right here with a deposit of $75. A deposit is a good thing. So she put $225 in there, plus she made a withdrawal 2 days later. So that's plus negative 90. Plus she wrote a check for 115. So that's plus negative 115. And then she wrote a check for some gas. So that's plus negative 70. And then she made a deposit. So that's plus 75. Or you could have gone 225 minus 90 minus 115 minus 70 plus 75. Either way, they're the same thing. This is a deposit. This is a withdrawal. Money was taken out. Withdrawal. I'm just going to do W. W withdrawal and a deposit. Okay, so I'm going to take all my deposits and I'm going to add them up. Okay, so what did she deposit in all? 225 plus 75. So she deposited $300 overall. That's a total deposit. And what did she withdraw? I'm going to work it over here. So she withdrew 115, 90, 70. That's 5, 10, 17. Carry the 1. She withdrew a total of $275. Okay. For some reason, I feel like I skipped something. 225, 90, 115, 70, and 75. Okay. All right. So this was a total withdrawal. So all I have to do is subtract. So that's 300 plus a total withdrawal of 275. Or you can put 300 minus 275, which means that her ending balance after her last deposit was a whopping $25. I was just checking my numbers again. Make sure I added all of them. All right. Let's take a look at 10. 10 says a cliff diver dives from a ledge that is 45 feet above the surface of the water. Here's my water. There is 0 feet. And let's see that. Say that's 45 feet above. Okay. That's positive. You're above. The diver reaches a depth of 15 feet under the surface of the water before returning to the surface. Okay. So he dives off the cliff and he goes under 15 feet. So that would be a negative 15 because he's underwater. Okay. So this would be negative. It says write an expression that can represent the distance between the diver's high point and low point. Well, this was his highest point, and this was his lowest point. So I want the distance between those two. Now, I don't care like which order you subtract in. Just know that with distance, you're going to subtract, and you're also going to use absolute value. It's always with distance because distance can never be one thing, and it's negative, guys. So you could write 45 minus negative 15 because you're subtracting a negative, put it in parentheses. Or you could write negative 15 minus the other number, which was 45. So this would just be 45 to the right. And of course, minus a negative is the same as a plus. So you would end up with the absolute value of 60, which is still just, they're 60 feet apart. The high and low point is 60 feet apart. Or you could have said that goes to the left, that goes to the left. So I end up with the absolute value of negative 60, which is still 60. That's still 60 feet apart, no matter what order you subtract in. Because you're going to use absolute value, the order in which you subtract doesn't matter. Just subtract the two numbers. And please make sure you put negative 15 I hope the diver doesn't go under the water 15 feet, but then you represent it as a positive 15 because that means they didn't go under the water. They stopped midair. Okay, don't do that. Let's take a look at 11. You pause the video and try that one. All right, it says a hot air balloon is 200 feet in the air. It's 200 feet in the air. I'm pretty sure that's going to be a positive 200. A diver is 35 feet below the surface of the ocean. I know that's going to be negative 35 feet. They're below the surface of the ocean, guys. We want to write an expression that represents the distance between the diver and the hot air balloon, and we'll solve. So again, use absolute value. Distance means you're going to subtract, just like you do with difference. Okay, but no absolute value with difference. Only absolute value with distance because the distance can't be negative. So I'm going to go with 200 minus the other number. Since you're subtracting a negative, put it inside of parentheses. Or you could have written negative 35 minus the other number, which would be 200. Just put the other number last instead of first. So that's going to give me the absolute value of 235, which is just it's 235 feet apart. This is the same as plus, guys. 200 plus 35 is 235. All right, both of these go to the left, so I'm going to add, same direction, add. So that would give me negative 235, but the absolute value of any number is always positive. So either way you subtract, as long as you're using absolute value, you get the same answer. All right. You're going to look at number 12, pause the video, and try it on your own. And it says the temperature during the day is 5.4 degrees Celsius. So that's where it starts. After sunset, it falls 7.5 degrees Celsius. If it's falling, it's going down, guys. But then the wind chill makes the temperature after sunset feel 6.3 degrees colder than the temperature. So it makes it feel even colder. So that's even less. What temperature does it feel like after the sunset? Okay. Just looking at what it feels like. Well, it starts off at 5 4/10, and then it falls 7.5 plus negative 7.5. But it feels, or plus it feels even colder. It feels 6.3 degrees colder. So that's going to be negative 6.3. Gonna make it even, it's going to feel like it's dropped even more. Okay, so this represents where it starts. Here it drops. Here it feels like it's dropped even more. Okay, it just feels like it. That's why they call it wind chill. It's what it makes it feel like. Not necessarily that it's the actual temperature, but the wind makes it feel like it's that much colder. All right, so you could have also written it like this: 5 4/10 minus 7 5/10 minus 6 3/10. I don't need that. It's still where it starts. It's still a drop and still well, it feels like it's another drop. So I'm going to add up how much it's dropped in all. Okay. Negative 13 8/10. Plus, I know where it started. Okay. So that's left and that's right. I'm going to subtract the 2. 13 8/10 minus 5 4/10. Line your decimals up. Going to have to regroup here. And it's more to the left, or it feels colder than the temperature it started off being, or out being, which is 5.4. So I'm going to say that it feels like it's negative 8.4 degrees Celsius. That's what it feels like. All right, I'm going to reserve 13 through 24 for tomorrow. But if you want to, you can try those and just watch the video tomorrow to see if you got them right. Totally up to you. But after this, you do have iReady lessons I want you to do. So load it on your Google Classwork page. You should see where I've assigned iReady. It's not going to show that right now, but you will see an assignment, and once you log into iReady, you'll see a teacher assigned lesson. It's actually two. One is strategies to add and subtract rational numbers, and the other one is a practice. So today I just want you to work on the one that says strategies to add and subtract rational numbers after you watch this video. Tomorrow you can actually do the practice, okay? All right, thank you.